So what is a buffer? Well, a buffer is a system that maintains a nearly constant pH in a solution when relatively small amounts of acid or base are added to the solution. So this is actually super crucial for natural habitats, because if you think about it, we've all heard of acid rain before. If there were no such thing as buffer systems, acid rain, just one rainstorm that had acidic rain in it, would kill an entire ecosystem. So it's pretty amazing how nature works. So this is actually a concept that we learned from nature. So a buffer is a mixture of its weak acid. Remember, we call weak acids HA and strong acids HX, and its conjugate base. So weak acid and its conjugate base, or a weak base and its conjugate acid. So buffers exist to protect systems. We would use buffers in science class because a lot of chemical reactions take place at a particular pH and in a narrow pH range, especially in living systems. So let's think about that. Like, your stomach is a good example also, and your blood is a good example also of buffers, natural buffer systems. If it wasn't for buffering systems in our stomach, you couldn't even drink a glass of lemonade. It would kill you because of the pH of it. So buffering systems help keep things kind of at a normal state. Same thing with your blood. So for example, you guys know that chemical reactions that we use in our body use oxygen and produce carbon dioxide. That's another way. The way we get carbon dioxide out of our system is related to buffer systems also. So we need to get the carbon dioxide that is a product of these chemical reactions out of our system. We need to get it to our lungs so that our lungs can expel it into the air, and the buffer systems are part of that whole concept. So when pH shifts, sometimes other reactions occurred or not desired. So buffers help control that also. And a good example of this is enzymes in the body. If the pH becomes a little bit off, it denatures or wrecks the enzymes. So if we make a weak acid and its conjugate base, if we add both of these things to a system, they both remain present in the system. This is a list of our strong acids. If you don't know the strong acids yet, you need to get those under your belt. So remember, this buffering system, though, is not strong acids. So strong acids are not good for making buffers because the conjugate bases of strong acids do not have the ability to consume any H pluses, and vice versa for bases. So we look for weak acids, and then we look for their conjugate base. But we can't just pull a conjugate base off the shelf. So you cannot pull a conjugate base off the shelf, so we need to have a salt of the conjugate base. So first of all, if we're going to make a buffer system, you pick a weak acid or a weak base, and you pick it with the desired pH range. We'll go over in a minute what the desired pH range means. Its conjugate base, which would be A minus. So remember, weak acid's HA, its conjugate base is A minus. And we would have to go to the shelf and pull a salt of that conjugate base. And that's because negative ions cannot exist alone in a compound. So we need an ionic compound with a neutral spectator ion as the ionic compound. So sodium or potassium are readily available. They're cheap. They're quintessential spectator ions so that they don't take place in any of the reactions. Therefore, they don't mess things up. So let's say we took acetic acid. Acetic acid is a weak acid because it's not one of our 6 strong acids. Its conjugate base is the acetate ion. So I would pull acetic acid off the shelf, and I would pull sodium acetate or potassium acetate and make that into my buffer system. So the pH range that I'm talking about is plus or minus 1 of the pKa. So remember, the Ka is individual to a specific acid. The pKa is the negative log of the Ka, and the pKa for acetic acid is 2.70. That means that you add 1 and subtract 1. That means the buffer will keep the solution between 1.70 and 3.70. So that's how I pick. I get to figure out which pH range I want to protect in, and I can pick it off a list of Ka values. Okay, let's try one more. So different buffer systems protect solutions from different pH ranges. So let's think boric acid. It's not one of our 6 strong acids. It is a weak acid. And then sodium borate. You can put sodium on each and every single time. So it protects between 8.2 and 10.2. Therefore, the pKa must be 9.2. So we look up the Ka. It's 5.8 times 10 to the minus 10. In order to get the pKa, I take the negative log of 5.8 times 10 to the minus 10, and I get a pKa of 9.2. There's the range. So it's about as simple as that. At least for us at this stage, we're just going to learn about what makes a buffer and how it works. So here's what happens. How does this work? Well, let's say you add a strong base. Remember, strong bases have neutral cations. So when you add a strong base into the solution, the OH minus is the only thing that is a concern to us. So when you add the OH minus will find that weak acid, pluck off an H plus, convert that OH minus, which would shoot the pH way up, into water, which is neutral, and leave behind more weak base. So the strong base is consumed, leaving behind more weak base, like such. So anytime you add an OH to a solution, you know it's going to look for an H plus. So the OH in this case is going to pluck the H plus off of HA, leaving behind more conjugate base and water. What if we add an acid? If a strong acid is added to the buffer, remember, all we concern ourselves with is H plus. The conjugate of a strong acid is neutral. When I add H plus to it, the H plus will look for the conjugate base A minus to produce more weak acid. So you can see that the strong acid that would plummet the pH is consumed, leaving behind more weak acid, which is part of the system anyway. So the H plus will get absorbed by A minus instead of plummeting the pH by forming H3O plus. So here's what it looks like when you add a strong acid to this buffer system. So it's kind of an interesting concept in that this buffer system can protect from H plus and OH minus. So if you were to go in back in the storage room, chemical storage room, you would see that I have buffers back there that I use. You can purchase them or we can make them, but this is how you make a buffer. And if anybody has a pool or a hot tub at home, you know that those also need to be maintained at a particular pH, and those are helpful in those situations also. So, summary, chemical buffers protect from pH changes within reason. You can't just dump a bunch of H plus or OH minus. It does protect it, just like floor buffers protect the floor with wax. Chemical buffers protect the system from pH ranges. So that's what that term buffer means.